Hello, everybody. My name is Wilde, and I'm happy to speak at the EDA Summit 2023. And today I'll be talking about cloud events, one event to rule them all. And I'll explain what I mean by this, of course, in a minute. Before I do that, just a very brief slide about myself. So I have been in the API space for a long time. I run a YouTube channel called Getting APIs to Work. If you want to find out more about APIs, you're interested in some videos, feel free to check it out. I talk about everything and anything in the API space. But now let's jump into today's topic, which is cloud events. And I want to discuss this. It's a standard that standardizes an event model. And I want to talk about this in a very simple way. First, I want to discuss a little bit why you would even want to do this, why it's a good idea, and why people are using it. So it has been around for a little while already. Then we'll look a little bit at what cloud events really look like. We'll look a little bit at what the spec defines and how you can use cloud events. And then I also want to talk a little bit about how to actually use them in practice. And that is, I think, something that's really interesting, in particular for larger organizations who are going in the direction of event-based architectures. And this also is my starting point of the discussion. When you talk about event-driven architecture, event-based architecture, however you call these, it's one of these topics that is definitely on the rise. It's relatively early on, so to speak, in that well-known hype cycle that we all know for Gartner, so it's still on the rise. You hear a lot about organizations using events here or there. They also typically use some other API technologies, but it's something that it's definitely picking up, and it's important to think about what that means. And it's something that I and my colleagues have been thinking about for a long time, actually. So a little while ago, we wrote a book that's called Continuous API Management. And the idea that we discussed in this book was this, that there are APIs and then there are API landscapes. And in most organizations today, you will have API landscapes, meaning that you're not just looking at individual APIs, but what you really want is you want to maximize the value of your API landscape. And it's important to understand that this is different from individual APIs, because if you look at a landscape, there's an evolution in API styles. Like I said, events are definitely picking up in momentum. We've seen the same thing maybe a couple of years ago with GraphQL suddenly becoming very popular. We definitely still have a lot of REST-based APIs around. So the world gets a little bit more diverse, and it's important to plan for this diversity. And it's also happening that API design and development happens in a more and more decentralized way. So that's also an important thing to keep in mind. There's not just one team doing the event stuff or one team doing the GraphQL stuff, right? So you want lots of teams, and you want to empower them to do things that still work well in the context of the overall landscape that you're managing. And all of this plays into this idea of API governance. So how do you do this if you are in a large organization? And how can you help that these things, on the one hand, are a little bit under control, but on the other hand, also are able to evolve, and you can use more than one technology or one solution? Which brings me to my next slide, which shows you a little bit of how messaging looks today. It's important to realize that, like APIs, messages or events, whatever you call those, nowadays are actually something pretty diverse. So it's not important to look into exactly what's going on in this slide, but I just want to draw attention to the fact that in many cases nowadays, events are propagated through multiple systems, multiple protocols, multiple ways how these events are actually being transmitted. And then the question is, can I do that, right? Is that something that I can do with my events without having a problem when suddenly I get an event through an MQTT connection, and now I have to forward this event into my Kafka messaging fabric. And in the end, it may get delivered to a customer through a WebSocket. And is that event still self-describing? right? Is that event that originated, let's say, in that device, really something that the ultimate receiver still fully understands? And this is exactly where cloud events are trying to help. And I think it's important to realize that if you look at messaging and how it already is something fairly complex today, it's not a good idea to say, oh, we'll only do events or messaging with one platform, right? That's the only thing we'll ever use. Because typically the world will get more complex. Maybe your organization acquires another organization, maybe your organization gets acquired, maybe you're partnering with somebody, and suddenly you have to make several systems work with each other. And if you then have to say, oh, no, but we can only do events using system X, you have painted yourself into a pretty unfortunate corner. And this is really where cloud events come in. They say it's a good idea to design events in a way that you can use them anywhere across multiple clouds, for example, but also across multiple protocols. And I think that's a good idea. And like I said, this is a topic that I've followed in different ways in a variety of technologies. And I think if you look at events, then it's a good idea to do the same thing. So what cloud events are doing is, in my mind, they are trying to manage events in event landscapes. If we reuse that word of landscape and mean by this something that's a little bit more complex, a little bit more diverse than just a monoculture of, oh, we only handle events in system X. And the way how cloud events do that is, I would say, relatively simple. I don't mean that in a negative way, but it's not that complicated. And I hope that I can explain all of it to you today. So what they do is they create a model for what they call context attributes that describe events. You can think of that, my way of thinking of it is a little bit like metadata for events. There's also an extension model. So if you think that this model needs a little bit richer information, you can extend it. Then there are format encodings, meaning that this model now can actually become something that is carried, for example, in JSON or in Avro or in protobuf, right? So depending on the format or on the encoding that gets on the wire somewhere, so to speak, it's still the same general model by separating this model and then these format encodings. There also are protocol bindings for different protocols that specify how to transport that model across a certain protocol. So these would be protocols such as MQTT or AMQP or Kafka or NATS or HTTP, right? And for all of these protocols, you get a definition of how this specific protocol should deal with cloud events. And last but not least, there also is the idea of supporting versioning so that if you evolve your event models over time, you can do so in a safe way, and cloud events give you, let's say, a good starting point for that. And after all this introduction, let's just look at an example. So this is a cloud event. I picked this right from the spec. And as you can see, in this case, it's encoded in JSON. And what you can see there are all these context attributes. Again, my way of thinking about these would be it's metadata about the event. So there's information about the spec version that's being used, about the type of event that occurred, about the source of the event, where it occurred, the subject, we'll talk about that a little bit later, and some other, and you can also see extension elements. And then you can also see the actual event data, which in this case also is JSON, and it's embedded in the event in like a wrapper element, so to speak, or wrapper property called data. So this is really how cloud events work. They take this model and map it into a, like I said, relatively simple serialization, in this case, JSON. And the value proposition that cloud events are giving us is that they say this unified model allows us to use an event format across different serializations and messaging fabrics. It allows us to easier integrate different things because now we actually have different components that talk the same model. They all talk cloud events. We also have the ability to achieve better portability across function as a service platform. So this was actually the starting point for cloud events, but I think that's not necessarily important nowadays, but this is how this whole thing actually started. And since we're all using this same model, it also means that we can use and implement better tooling because now we all use the same model. So if we archive things, if we analyze things, if we repurpose things, they all look the same way. So that makes it much easier to develop tooling. It also becomes something where for some models where there is not a good event model that has become kind of the standard, for example, for webhooks, it's something where it may be a good starting point to say, well, we use webhooks, and by the way, what we send across those webhooks are cloud events. To me, that sounds like probably a good idea. And because we have this shared model, it's also easier for us to enforce certain policies. So if we don't want to forward certain events, we want to filter them out for maybe privacy reasons or whatever, it becomes much easier to do that because, again, they all follow the same model. So in my mind, really, that's a pretty good list of possible things we get out of cloud events. And we'll now look a little bit more in detail into how they work. And then we'll also look into how you can get them to work. Okay, now let's look first at what cloud events really look like. And we'll dive a little bit deeper into kind of that example that we looked at. From this metadata that we have, there are only 4, it's really small, I'd say, there are only 4 required attributes that need to be present in every event. One is the ID that identifies the event itself. It has to be unique for a given source. Then there's a source, which is URI reference. So that one identifies the source where the event originated. Then we have this identifier of the spec version. Always a good idea to think about versioning from the get-go, and Cloud Events did that. Kudos for that. And we also have the identification of the type of event. So very often sources have more than one thing that they can talk about, more than one type of event that can happen, and the type allows us to distinguish that. And of course, the type then means there can be many events of that type, but they will be distinguished by the ID. In addition to these required attributes, we also have a couple of option attributes that we did see. So we have something that's called data content type that tells us how the event data is serialized. We saw the example with JSON. You can do whatever you like. You can also put it in there as a binary, as a blob. I've seen examples where people put it in there in XML. There's no limit to what you can do, but you have to identify how that payload is basically encoded, and that's what data content type is for. If you have a schema, then you can also link to that schema, but again, that's an optional property. There's something called a subject. So the subject, you can think of it as an additional filter. So let's say, for example, you would have temperature measurements from a sensor. And then for the subject, you could, for example, say that in my measurements, I would like to have a subject that tells me whether this measurement is like a critical value or an okay value. And then somewhere in the infrastructure, you could do some filtering and say, I only want to have those events where the subject actually tells me this is a critical measurement. So that allows you to more easily filter events without having to look into the payload. It's something that you will have to do at the source, and the source then will have to create that subject so that it can be used for filtering further down the pipeline. And the last optional property would be the time that allows us to say when the occurrence happened. Now, you can also use extensions. I won't go into any details here, but we saw them in the example. So the extensions are anything that is not covered by these core attributes, as the required and optional ones are called. And there is kind of a little community page that you can look at the Cloud Events site, or no, it's actually in the GitHub repo that they are maintaining. And that's the idea there, is that if there are extensions that will get established over time, maybe they will become standard at some point in time, but we'll see. But you can also, you just use kind of private extensions, but you will have to make sure that you define them using the type system of Cloud Events. And the type system is relatively simple. There's nothing in there you wouldn't expect, right? So you see here, it's a collection of 7 different types. So once again, Cloud Events is this abstract data model that lets you define event metadata, so to speak. And this event metadata has to be described using one of those 7 data types. And then when you serialize it, for example, into JSON, then it will get serialized into whatever that data format, such as JSON, allows you to do, right? So JSON, for example, doesn't have timestamps. So then the JSON format needs to say, how are timestamps serialized into JSON, which, if I recall correctly, are RFC 3339 timestamps, but don't hold me responsible for that. But I think that's how it works. But anyway, so this is how extensions work. And just a little bit more how this whole system is set up, of how Cloud Events actually work. So like I said, Cloud Events is this abstract model. Then there are the event formats. There are not that many that are specified right now. So every implementation needs to support JSON. So this is the example that I showed you. And then there also are event formats where it's defined how to represent Cloud Events data in Avro and in Protobuf. So these are the event formats that are there right now. And then there's another thing that's called protocol binding, which tells you how to transmit a certain payload with Cloud Event data across a certain protocol. And there we have a little bit richer set of things to choose from. So there are existing bindings that are defined for AMQP, HTTP, Kafka, MQTT, NATS, and WebSockets. So it's a good starting set, I would say. And again, if you have something in addition to that, maybe it will be supported later on. So new protocol bindings definitely may be published, or you define your own. Both things are fine. And last but not least, because I think it's sometimes, depending on where you come from, may be interesting to think of how this works. There are also things that are called content modes. And content modes talk about how does a Cloud Event payload get mapped into a protocol binding. And I'll explain that to you with a very simple example, but which I think shows it very nicely and easily, which is with HTTP. So when you look at HTTP itself has a very neat way of representing metadata, so to speak, which is in the header fields. So if you think about how to transmit Cloud Events, you can either transmit everything in the payload, and that would be like this. Right, so this is called the structured content mode, where the structured data is all put into the payload, in this case, the body of the HTTP message that is being sent. But what you can also do, and this is another content mode of Cloud Events, which maybe in some cases may be advantageous, is to say, I actually want to represent all those metadata attributes of Cloud Events as HTTP header fields. And in that case, you end up with something that I think confusingly, but Cloud Events have called binary content mode. It's not really binary, but it is different. So in this case, as you can see, all the metadata is now transmitted in HTTP header fields, and Cloud Events have defined their own header fields. They're all, you see them here, and they're all can be easily identified by having this CE- prefix. And then the only thing that is still in the body is this content itself, and the content type tells us, well, this is some JSON. There's some JSON coming away. And this is kind of all there is to Cloud Events, so to speak. Now, let me conclude by briefly talking about how to get Cloud Events to work, I think, in large organizations. So I've seen it being used in large organizations, and I think it actually worked pretty well. So let's briefly look at how does it actually compare to some other things you probably have heard about. So async API. And I think it's really interesting to think about the interplay of these two things. So Cloud Events is about unifying this message model. Async API is about describing one single API. And there actually is not any kind of competition between those. There almost is no overlap, so to speak. And I think actually it's a very good idea to think about how to combine these two things. And if you look at Cloud Events, if you're an API designer, right, then what would you need to do? Well, if you look at the structured content mode, you would need to design all your messages to have those Cloud Events things in there. If you look at the binary content mode, you would need to define your async API differently, because now your message only contains the payload of the event, but now you need to use all these header fields. And luckily, async API has a nice model for that, which is called traits. So you can define a trait that contains all these header fields, and then you can reuse that for all the messages. So I've used this one here. This one is from Microx, by the way. Shout out to them. They provided that for the community. So this is an async API trait you could use, which combines all these different header fields that async API, that Cloud Events define, and puts them into an async API trait that you can then reuse in async API definitions. And there also is a JSON schema for Cloud Events. So if you decide to go the structured content route, there also is support in the JSON schema for the JSON encoding of Cloud Events actually has been produced by the specification writers themselves. So that also is something that you can easily find and reuse. And I think this really is the interesting thing to keep in mind. In my mind, and it's an interesting thing to think about who even uses these things. I think it's a little different. So async API is something that typically API designers will use. Cloud Events is something that it's more like the API platform managers, the API platform architects who will start thinking about, maybe it would be good if all of our events were working in a similar way, because that makes things easier to understand and use for everybody. And in my mind, that's really a very interesting route to go. So, and the way how you can do that is make Cloud Events part of the API guidelines and tell people, if you are using event-based APIs, please use Cloud Events. You can help them doing this by giving them some tooling, right? For example, the async API traits, JSON schema, some maybe validation and linting tools, so that they have an easier time to actually define their models. And in that way, you will be able to also find all these different events out there. And that also makes it easy for you then, as somebody who's, let's say, managing the API platform, to compile a list of all the sources, of all the types, maybe even of all the subjects that these things are using. And that then can become a super valuable resource for somebody using events within your organization, because now suddenly you have this overview of all the events that anybody is creating within your organization, instead of having to find out who's creating which APIs with events and which technology he is using, and then having a hard time getting organized in that landscape. And with that, I am done. So I think in the end, my message to you is there is one to rule them all. And in that case, it's that event model of Cloud Events. And I think it's a really interesting thing to at least keep in mind, right? So events are still on the rise. Don't paint yourself into a corner of, oh, we only use one system for event stuff. That I think would not be a good thing to do. CloudEvents provide a good unified event model that you can use. And in particular, if you look at this interesting combination of CloudEvents and async API, you can combine these things very nicely to help people to build better APIs with CloudEvents. And with this, I'm done. Thanks a lot for listening. I hope you found it interesting. I hope you also find this whole event interesting. I think it's always great to see these events being put on. Thanks for having me on this event. And if you want to find more information about myself, you can find me on Twitter, on YouTube, and on LinkedIn. And you can also find the slides online at the URI that you can see here. That was it. Thanks a lot, and have a great rest of the event. Bye.